This question here is important because it covers one of the most classically covered areas of complex numbers: solving for unknowns to satisfy a certain equation. As you can see, it's worth 6 marks. So that's roughly 8% of the paper as a whole. To begin with, we have to ask ourselves, what is W? Well, W represents a complex number that is unknown at present, so we don't know the specifics. With this in mind, we can say, let W equal x plus iy. Now that's W sorted, but what about W conjugate? Well, W conjugate must then give me x minus iy, because all a conjugate does is flip the plus or minus sign. So then, we have W. We have W conjugate. What's next? We need to plug in both W and W conjugate, as this allows us to expand the equation in terms of both x and y. So we can solve for x and y, which means we can solve for each complex number which they want. Now, to do this, we plug in our values for both W and W conjugate. And when we do that, we get the following. Now here's a thought. Is this equation fully complete? Think about that for a second. Pause the video and see if you can figure out what might be missing. Now that was actually a bit of a trick question, because the equation is correct. However, another way to view this equation would be to say that we technically have x squared minus y squared plus 2y plus I times 2xy plus 2x, which is equal to 1 plus 0i. This here allows us to, more easily compared to the previous form, equate both the real and the imaginary components because they correspond. X squared minus y squared plus 2y corresponds to 1. And 2xy plus 2x corresponds to 0. Now, why would we need to equate both the real and imaginary terms separately? It's because this is going to give us simultaneous equations, which will then allow us to solve for x and y. But what does that actually look like? Well, we've firstly got x squared minus y squared plus 2y equals 1, as these both represent real numbers. And after this, we have 2x plus 2xy equals 0, which gives us x times 1 plus y equals 0, which gives us x equals 0 and y equals negative 1 for the imaginary side of the equation. So brilliant. We've now got a value for x, which when plugged in can help us find a value for y. At the same time, we also have a value for y, which can help us find a value for x. So if we plug in x equals 0, which we found earlier, we get 0 squared minus y squared plus 2y is equal to 1. Which means y squared minus 2y plus 1 equals 0. which gives y equals 1. On a similar note, if we plug in y equals -1, we then get x squared minus -1 squared plus 2 times -1 is equal to 1, which gives us x squared minus 4 equals 0, which then gives us x is equal to plus or minus 2. But considering that the question says that the real value of w must be less than 0, therefore w is equal to 0 plus I, or w is equal to -2 minus I.